Hi, everyone. Can you hear me okay? All right. So very nice to be with you today. I hope you had a nice lunch. My name is Cedric Monier. I'm part of the product management team at Axway. I'm spending most of my time with our large customers, helping them implementing their API platform, helping them in their API first program, and sharing with them the vision of where we want to go with our solutions to get their input and to build the future with our customers. Today, my talk is going to be about SOA, API management, microservice management, lessons learned, and how to succeed. So basically 3 waves, SOA, API management, microservice management. And before I start, I'd like to do a very quick poll, just to see what kind of audience we have. Who has still a SOA within its organization, a SOA implementation within the organization, and have an ESB in production? How many people? Okay. On the other side of the spectrum, who is implementing a microservice management stack, is transitioning to a microservice architecture, and is in production with microservices? Okay, about half-half. Okay, great. So 3 waves. Well, as enterprise move left from right, from SOA to API management to microservice management, well, there's some tension that can arise within the enterprise. You can even have very passionate debates with your architects, with your IT stakeholders, with your developers, with people that protect SOA and the investment in SOA and the ESB. And these guys are right. I mean, you shouldn't completely get rid of your ESB, and you should leverage the reusable services that you built with your ESB. Some people will push for APIs so that you adopt APIs because they are simpler, because they are more mobile friendly, and they will support your digital initiatives. And they're right too. I mean, you need to deliver the value to your business users. You need to transform your user experience, and APIs are the heart of that. Some people will be very opinionated and say, well, you shouldn't implement an ESB, and they have some reasons to say that. And also, you have more and more people that start to adopt microservices, and people that realize that deploying microservices comes with its own set of challenges in terms of security, in terms of monitoring, and these guys are right too. And you may end up with, at the end of the day, with a big headache, and we don't like headaches. So instead of, just having this passionate debate, let's look at each of these waves, one after the other one, and summarize what are the good things and the challenges associated with each of the waves, so that you can make the right choices. SOA. There are lots of good things about SOA. I mean, the idea of SOA is to provide flexibility and reusability through 9 design principles: standardized service contract, reusability, discoverability, loss coupling, autonomy, composability, service abstraction, statelessness, and interoperability. All of these design principles are great. They're still valid today. They're valid in the API management world. They're valid in the microservice management world. You want to keep that. You want to keep this approach to building your architecture. There were a good set of standards with SOA, with SOAP and XML, a good set of tools as well available, especially for the enterprise, with the enterprise service bus and the business process management tools, if you wanted to have an easy way to change your orchestration layer and your business processes. All of that was good. Now, there were a few challenges also with SOA, and I've been I've been promoting SOA in a couple of organizations, implementing ESB successfully in a couple of organizations as well. And there were some challenges. I mean, we were successful with it. We could implement the ESB. We could build reliable, reusable services. We could build integrations between applications that were very reliable. But there were a few challenges. And now that I've been working on API management for a couple of years, it's a lot clearer what these challenges are. Let's look at them a little bit. The first one is the lack of simplicity for the clients. I mean, when you want to invoke a SOAP API or invoke a REST APIs, it's much easier in the REST world. If you are a developer, you can use a simple curl command. You can go and very easily, programmatically call the API from a browser, from a mobile app. All of that is much easier with REST. The second aspect is latency for the clients. And that's very important, because if you have an API that you expose to a mobile app, and this mobile app becomes, you have a good adoption behind this mobile app, maybe you will have tens of users, hundreds of users, millions of users. And as this adoption grows, your throughput will grow very rapidly. To give you an idea, some of our customers today, they manage 1,000 TPS, 5,000 TPS, 10,000 TPS in production every day. They have 10,000 per second transaction calls on the API platform. And if you reach these kind of volumes and want to have a latency below 30 milliseconds to have a good experience for your user, well, you're better off using REST than using SOAP. The second aspect of the tooling is the ESB, don't get me wrong, and they're great. They allow you to build reusable services in a very reliable manner, to build integrations thanks to connectors, to data transformation. But there's something that they really lack. It's the ability to easily discover the catalog of services, to try the catalog of services, to request access to the catalog of services. They completely miss these kind of capabilities, and that's what API management provided in the second wave. In terms of standards, WS Star over-complexified SOAP, I think. With REST, it's much simpler. You have TLS, and then you use header-based authentication, and it's a much simpler approach than all the complexity that was around, the WS Star standard that over-complexified SOAP and were, an impediment to the adoption, I really believe. Last but not least, SOA and SBS in particular, they were born in a different age. You were not worrying about deploying, the middleware on the cloud, making it elastic, easily connect to cloud applications through REST API. So all of that was born at a different age, and it's one of the challenge of SOA implementations today. Now, if you have an ESB today, you shouldn't replace it. There are ways to go around some of these challenges by, for example, if you have a good set of reusable SOAP services, by building REST API on top of it, using caching to address some of the latency issues, and all of that can be implemented in the API management layer. So you don't necessarily need to have a rip and replace strategy. You can leverage your existing assets and build a layer on top of it that will overcome some of the challenges that are listed here. API management, that's the second wave. With API management, what we're trying to really address is enabling digital initiatives. How? By exposing services that are available within the enterprise, whether they are built with microservices, that are available in legacy applications, or available from your ecosystem, and expose these services to your consumers to transform the user experience, to differentiate, to provide a new user experience on mobile apps, on web apps, on bots, virtual personal assistants, wearables, IoT, you name it. Make your services available and very easy to consume on any device. It's also about exposing your APIs to your ecosystem so that you can address new markets, so that you can allow your ecosystem to also differentiate in terms of user experience and address some of the challenges that you may have internally in building the right user experience for your users. And when you have these two sides of the equation, on one side you have an explosion of API. You have a very high number of APIs that need to be managed, that need to be secured, that need to be monitored. And on the other side, you have an explosion of API consumer. And API management is about having a layer in the middle where you can have a complete an API catalog where you can register your API, manage their lifecycle. You can have a consumer registry where you're going to authenticate consumers of your API, authorize them to use certain methods of your APIs. Protects against threats, because as you expose your APIs externally, there are lots of threats coming from all over the world that you want to protect against. Do mediation of protocols so that you can propagate the identity of the user all the way to your backend system. That's an area where, especially if you have a lot of heterogeneity on the right side, you may have a lot of challenges in transforming the identity of the user that you authenticated on a mobile app to what your backend is able to understand. Another challenge which will be presented by my colleague tomorrow, Chris, is how do you integrate with external token management system, and how do you interact with Okta or with Ping or with another solution that you have within your enterprise, both at the design time and runtime, and how do you integrate well with your API management layer. Last but not least, it's about providing you with an ability to compose API easily, rapidly, take a couple of APIs, build a higher value API that will abstract the complexity and address some new business needs that you have within your organization. On top of that, a layer of analytics and predictive insights so that you can, for example, get an alert if you are getting very close to your SLA, reaching the limit of your SLA, or just understand the behavior of your API consumers and understand when they are using the API. Is it more in the morning? Is it more in the middle of the day, the end of the day? And are there variations in that in different seasons, so that you better understand the behavior of your consumer, and you can take that into account into the design of your products and your APIs. So that's API management, summarized at a very high level. Now, what are the key things that we've learned about API management these last couple of years? Well, the first aspect is that a couple of years ago, when I was talking with customers, like 4 or 5 years ago, all of our customers were organized the same way. They had a small API team. They were, building. They were very efficient, very fast. They could very quickly take an API, expose it very securely at the edge of the enterprise, and they could do that very fast. Very fast. They were very efficient, and they were very, very well trained to achieve that and do that in a repetitive manner. But over time, the needs of building APIs and securing APIs within the organization has exploded, and this small team cannot keep up anymore. What you need is to address tens of developers, hundreds of developers that need to build API and that need to have access to the API management platform. And what you need to do is to transition to a self-service approach, where your developers, instead of relying on a small central team, they can consume the API management layer themselves. The API developers will just register their API in the API catalog. They pick all the API management capabilities that they need. They need to do that very quickly to be able to run and deliver their digital initiatives as fast as possible. So what does that mean? What does self-service mean in the API management world? Well, in fact, there are two sides of the coin. The first side of the coin is the consumer side. Provide self-service for consumers of APIs. And that side of the coin is very well understood by most API management vendors, and it's the heart of the API management solutions on the market today. The idea is to have a portal where you can very simply onboard API consumer, provide them with an API catalog where they can discover the APIs, they can very easily understand the business value of the API, they can try the API, they have an interactive documentation through OpenAPI v3 specification or Swagger specifications. If you want to go all the way to providing products, you also have the ability to manage usage plans and billings. If you expose your API to your ecosystem, you need partner management so that you can manage partners that onboard on your catalog, manage their permissions, how they can discover APIs, how they can request access to their APIs, and make that process very seamless. If you want this process to be seamless, you need to have delegated administration so that you can have, for a given partner or a given business unit, multiple consumers and an administrator of these consumer permissions. And if you care about your developers, you're better off providing snippets so that they can very easily invoke the API through a very simple curl command that is automatically generated from the catalog. Or you can generate an SDK so that you accelerate and you secure the development of mobile apps, and you automate calling the API with the right level of security on the client side, on the mobile side in particular. That's really the summary of what you need on the consumer side if you want to scale and have a great experience for developers that consume your APIs. That's one side of the coin. The other side of the coin is more the provider side. And that's the area where all vendors are not equal and where we see a big difference and a big focus in our customer base since a couple of years. The idea is to allow developers to simplify the life of developers, basically. And developers of API shouldn't have to worry about security. Instead, what they should have is a very simple way to register their API in the API catalog through an API or through a CLI. CLI is even better, so that it's very easy through a few commands to register in the API in the catalog. And once the API is registered in the catalog, what we do in the API management layer is automatically apply security policies on top of the API. And we enforce these security policies so that it's mandatory to execute these security policies, to authenticate the user, to authenticate the app, to authorize the user, authorize the app, based on all the policies that you have defined within your organization. And this needs to be done automatically so that you don't have manual errors in the process of deploying new API proxies. If you want to do that efficiently, you need to have dynamic security policy enforcement. To give you an example, when you authenticate a user, if this user is an employee versus this user is a customer, you will apply different permissions to an employee versus a customer. Another example is you authenticate an end user who is an employee. Well, this employee may be consuming your API from the internal network, versus this employee is consuming your API through the internet. And if you are in a very highly regulated market, in a bank or in a healthcare, well, you will have different permissions depending on where they access the API from. So dynamic security policy enforcement is about being able to expose your APIs all over your enterprise, manage all these consumption models in a very dynamic way so that you can expose your API broadly and you can still manage the security and rely on the dynamicity to really apply the security policies that are mandatory for you. The next aspect is DevOps friendliness. It's super important to make it very easy for your API developers to store their API definition in Git, deploy these APIs very easily in a test environment, automatically test it, and automate that process through Jenkins. That's really key, the CI process. And then to deploy the API in production in a granular fashion without downtime so that there's no impact for your users, even when you update an API. And it's really essential to make that process very easy, very smooth, very simple. Delegated administration so that the API provider can manage the permissions of who can see the API, who can consume the API, without relying on a central team, same thing. And then delegated monitoring, this one is absolutely key, because you don't want them to be blind. Once they register the API in the API catalog, the API policies are automatically applied. They need to understand if they cannot reach the API, why they cannot reach this API. Is it because they are not using the right authentication method? Is it because they have an error in the way they submit the API? And all of that all the information to do the troubleshooting needs to be available to the API developer without having to call a central team. And they also want to understand the behavior of their API, in various production and in the various environments you deploy the API to, and understand the behavior of the consumers of the API. All of that is key so that you can really, scale at the right level with your API platform. We really believe that if you want to be successful in the API management space, you need to focus on the left side, of course, that's a given, but also on the right side, and provide an experience to the API developers where it's very smooth to leverage the API platform through all these set of capabilities and deploy APIs all the way to production in a matter of a couple of days, thanks to all the capabilities that are listed here, without having to call a central team, in total autonomy and with a lot of simplicity. That's really the key on the right side. And if there's a lesson learned this last couple of years, most of our customers, they really invest on the right side of this diagram. So that's API management and sort of where we are on API management. Now, microservice management, that's the next wave. I like this diagram, this slide from Gartner that summarizes well the transition from SOA on the left side to microservices on the right side. With SOA, you have logically encapsulated services, but you still have monolithic deployments. I mean, you tend to deploy monolithic applications on production. You have large grain deployments. You have logically coupled, interactions between your services. You are still very request-driven, and you have some level of shared data between your various services. On the other side of the spectrum, if you go all the way on the right side with microservices, you get rid of the monolith, and what you deploy is very fine-grained functions that are completely independent of each other. It's very easy to deploy a new microservice. It's very easy to update a new one of your microservices. They are completely decoupled. They're completely event-driven, and they are autonomous in terms of owning their own data so that they can be independent of each other. When you are on the right side, you can really address what they call web scale, scalability at high throughput, scale depending on your demand, and scale to any business need that you may have. In the middle is where a lot of our customers are landing, because it may be a challenge to go all the way to the right side. And an approach that is sort of the middle ground is to have what we call mini services, where you break your monolith, so you have smaller services that you can deploy independently of each other. You have more of a coarse-grained at the domain level or subdomain level, but you have loosely coupled services. You have request-driven traffic between your services rather than an event-driven approach. And each of the mini services will own their data so that they are independent of each other. There's nothing wrong with the middle approach, and it provides a lot of agility. And a lot of our customers today, we see them speaking about microservices, but what they implement is actually a mini service because they are still in transition towards the microservice approach. I thought this slide was interesting to really explain the difference between these different level of maturity. Now, if we look at the challenges associated with microservices, well, I just spoke about the API management. And API management in the monolithic world is focused at the edge. What you do is you expose your API at what we call the internal edge, which is the consumption by internal application, or at the external edge, which is the consumption by external application, mobile apps or partners. And you protect your APIs at this level. But the number of APIs that you manage is relatively small. And what you have behind is monolithic applications. Well, with microservices, you're going to have an explosion of APIs. You're going to have a much higher number of APIs. These microservices are going to be completely independent of each other, and there's going to be a lot of challenges in terms of managing the traffic between your microservices, managing the security of your microservices, and managing, the monitoring of these microservices. If we look in a little bit more detail, the differences at each of the layers. At the external edge, of course, you have a lot more threats. You can have attacks from the external world, and you tend to protect your API with a high level, of protection. Internal edge, you have less threats. You have consumption by your applications on your internal network. You still need to have a good level of authentication authorization, but you're less worried about attacks. Well, with microservices, the number of threats tend to explode again, and that was quite surprising when we started to talk with some of our customers. Why? Because you have a limited set of external attacks with your microservices that are protected on your internal network, but you have a lot of microservices. You have a lot of consumer. You have a lot of potential wrong way to call the API, to call the microservice, and you have potentially a lot of problems internally in the consumption of your APIs, and you really need to carefully assess what are these threats to protect against them, to protect against misusage. The other aspect is scalability. At the edge, you scale based on consumption, based on how many times your API is going to be called per second, how many times your API is going to be called per day. It's easy to plan that, to scale your infrastructure based on your needs. When you have a microservice approach, it's completely different. You want your microservices to be independent of each other. So you don't want to have a central point and a central load balancer or a central point where you do all your security. Each microservice needs to be independent of each other. And you want to scale based on the microservice that you deploy. And if you need a microservice instance to be scaled up and down, well, you need the right level of protection for this microservice and not rely on a central point, which is more the gateway model that we currently have. So you need to transition to a different kind of middleware, which is more a micro gateway that you couple with your microservice that is very easy to deploy with your microservice and your orchestration layer, whether you use Kubernetes or Mesos or Swarm. So let's look a little bit more at what we mean by managing microservices and managing the challenges associated with microservices. This is a very simple diagram. You have a service A that needs to call a service B. With microservice, it's very different from a monolith, because between the service A and the service B, you have the network. And we all know that with the networks, a lot of things can happen. You can have outage, you can have problems. And the service A can scale independently of service B. So you can have 10 instances of service B, or 9 instances, or 20, or 100 instances. So you need to be able to manage that aspect of the communication with service B when you call service B from service A. And when you look at really all the aspects that you need to manage in the microservice to microservice communication, what we call the east-west traffic, you have to manage service discovery. So that you can discover your services. You have to manage retries, you have to manage timeouts, you have to manage load balancing. You have a whole set of services, of challenges that you have to address to have a reliable communication between your microservices. Of course, there are solutions to address that. The first solution is to leverage open source. Take the Netflix stack, and just take Eureka for the service registry, take Hystrix for circuit breaker. You just assemble all the Netflix stack, you use all the open source that is available and broadly available now, and you just take all this open source and assemble the puzzle to address some of these challenges. The problem with this approach is that you're going to have to integrate within your microservice a lot of libraries, all the client libraries to do the client side of the service discovery, to do the circuit breaker, etc. And all these libraries, well, they create a dependency, they create conflicts with your actual microservice, and they create a lot of challenges in terms of deployment. Also, if you are lucky and you develop in Java, well, all of this stack is available with Netflix. But if you develop in Node.js or in Go, well, you have less of these services that are available for you. That's one of the challenges of this approach. A second approach is that you take a single stack, like Spring Boot, and everything is pre-integrated. It's much easier to manage, the dependencies with all these third-party components that you have. It's already pre-integrated. It's easy to deploy on this single stack. If you are using Java and developing in Java, it's probably your best option. But there are other options that have come recently that are much more interesting. And this option is Istio. The idea of Istio is to really have a sidecar that will completely manage this aspect of the service-to-service communication, make it very reliable, make it very easy to monitor, very easy to secure, and completely remove that complexity from your microservice. So the microservice will delegate to the sidecar managing all this complexity, and you will have very, very little impact on your actual microservices. This approach is very recent, but it's much more promising. And we believe that with the community behind Istio, with the history of Google of supporting large communities like Istio in the past, this Istio is really going to become the market standard. The other aspect of Istio is that you're not bound to one language. You can use Java, you can use Node.js, you can use Go, you can use .NET if you want to. You can really choose the language that you want to develop your microservices. Another aspect is that it's better at server-to-consumer security. It implements the security on the server side and the consumer side, and it provides that out of the box for you. Another aspect that we really liked in Istio is that it has a great set of APIs, and it has an extensible policy approach where you can enrich the policies, and that's really great for us to plug into Istio and provide added value on top of it. So the idea is really to remove all this complexity for your microservice developers. They can just sell. Istio means selling in Greek. They can just adopt the sidecar and sell with it, relax, and focusing on address their business needs in their microservices. Istio provides a lot of capabilities like connecting services together, doing the service discovery, the load balancing in each of the pods that you would deploy in your Kubernetes cluster. Manage the traffic, do the monitoring, and manage the security for you. All of that is managed in your sidecar, and you don't have to worry about it in your microservice. I like this slide because it summarizes well what I've just said. In the SOA wave, you have basically a smart pipe in the middle, the ESB, and you have dumb endpoints. At the beginning of the microservice architecture with the netlist approach, we sort of reversed the equation, and we had smart endpoints that could communicate with any microservices, and you had dump pipe. With what is called in this diagram cloud-native architecture, which is more the service mesh approach, what you have is an infrastructure that manages all the complexity for you, and you can focus on delivering value in your microservices. They manage all the complexity of communicating between microservices, and your microservice don't have to worry about that. Now, how do you combine the two together? How do you combine microservice management and API management? Because in your microservice, you have a lot of APIs. These APIs, people need to be aware of them. Must be very easy to discover them. Well, what we believe at Axway is that you need a multi-layer approach. First of all, you need to be able to deploy on any cloud. It's a given now. You shouldn't be locked into a particular vendor. You should be able to deploy on AWS, on Azure, on Google Cloud Platform, any platform that you have. And you want to deploy on this platform using Kubernetes, all your microservices, and have the service mesh that provides the reliable communication between your microservices. And for that, we decided to adopt Istio and Envoy. And either you use the Istio layer that is provided by AWS or by OpenShift, and we will integrate with it with a mesh agent. Either you don't have a service mesh, and we can provide it for you. And on top of that, what we do is that we add a policy engine so that you can manage policies that are not pre-built in Istio. We have a lot more capabilities in our API management stack that will allow you to protect your APIs and to manage the traffic between your APIs. And we're going to allow you to manage the complexity of your service mesh at scale in a much easier way with what we call microservice management. The idea is to allow you to couple microservices together and to apply policies on a set of microservices so that you can manage the ingress traffic, the egress traffic, and the traffic at the edge of a particular domain and better control the consumption around your particular domain. What we plug into this through the mesh agent is a management layer on top of it with a service registry where all the services will be automatically discovered with the ability to apply policies on a set of services and easily manage all the traffic in your service mesh. An API catalog where your API will be registered, where you will co-locate the API from your service mesh with the API from your monolith, including your ESB if you still have one, and the APIs from your cloud applications. All of that will be in a central catalog so that you can expose all your services and easily manage the onboarding process and the authorization around these services. And of course, monitoring around so that you very easily monitor the traffic that is going through your service mesh. At a high level, it's about easily protecting and monitoring your service mesh at scale so that you can very easily define policies, very easily monitor your traffic, and connect your service mesh to your ecosystem through the traditional API management stack. Thank you. If you want to come to our booth, you have a booth just after the door here on the left side, and we have another talk tomorrow about more the integration of API management with token management, and hope to welcome you at 11 something. All right. Thank you.